Let us start with perhaps the most astonishing example of literary prophecy ever recorded in 1865. Jules Verne published From Earth to the Moon, a novel about three men attempting to reach our nearest celestial neighbor. What makes this book remarkable is not the story itself, but how closely reality would mirror fiction. Exactly 104 years later, Verne's fictional spacecraft launched from Florida. So did Apollo 11. His mission carried 3 crew members. So did NASA's, but the coincidences go deeper than that. Verne named his spacecraft the Columbiad. NASA called its command module Columbia. The similarities were so striking that the space agency itself acknowledged them decades later, noting that the shape and size of Verne's fictional craft closely matched the Apollo spacecraft design. There's an even eerier connection. Verne's novel described a telescope tracking the spacecraft's journey through space during the Apollo 13 crisis in 1970. A telescope at Johnson Space Center observed an explosion more than 200,000 miles away, just as Verne had imagined. Sometimes, fiction seems to blueprint reality. Then there is 20,000 Leagues Under the Sea, published in 1870. Verne created Captain Nemo and his vessel, the Nautilus, a submarine powered entirely by electricity. This was decades before electric propulsion became practical for naval vessels. The Nautilus contained a library, an organ room, and all the comforts of a proper home. When the first nuclear submarine launched in 1954, the US Navy named it Nautilus in direct homage to Verne's creation. The fictional vessel had anticipated modern submarine life by nearly a century. Jules Verne was not merely writing adventure stories, he was conducting thought experiments about technology that would not exist for generations. While Jules Verne amazed readers with optimistic visions of exploration, H.G. Wells took a darker turn. His prophecies were not just about what humanity could achieve, but what it might do to itself. In 1914, Wells published a novel called The World Set Free. In it, he imagined atomic bombs, not just explosive devices, but weapons that would release the energy bound within atoms themselves. He described bombs that would continue exploding, lingering destruction that poisoned the land long after detonation. But here is the detail that becomes almost impossible to dismiss. As coincidence, Wells set his atomic war in 1956. He wrote this decades before nuclear fission was discovered. Yet he somehow sensed that the technology would emerge in the mid-20th century. The first actual atomic bomb test happened in 1945, just 11 years earlier than Wells predicted. Wells understood something deeper than the physics he grasped, the psychological and political weight of such weapons. His novel explored how nuclear destruction might force humanity to reconsider warfare entirely, or fail to. The book became both prophecy and warning, a pattern that would define much of his career. He imagined tanks as early as 1903, calling them land ironclads, in a story about technological warfare. Military planners initially dismissed the idea as fantasy until the trenches of World War I proved them tragically wrong. Wells also wrote about flight heavier than air before the Wright brothers succeeded, and he envisioned space travel when most scientists considered it impossible. Perhaps most remarkably, he conceived something like a global information network, a worldwide web of knowledge accessible to all. Wells did not just predict gadgets, he predicted consequences. He saw that every technology carries a shadow, and that foresight offers no guarantee of wisdom. The ability to imagine the future, he seemed to say, means nothing if we refuse to change our path. Arthur C. Clarke occupies a fascinating space in the history of science fiction, because he was never just a writer, imagining impossible things. He was a working engineer who understood the mathematics and physics behind his ideas. In 1945, Clarke published a technical paper that would prove remarkably prescient. He proposed that satellites could be placed in a very specific orbit, exactly the right distance from Earth, so that they would orbit at the same speed the planet rotates from the ground. These satellites would appear to hang motionless in the sky, always positioned above the same spot on the surface. This concept, which we now call a geostationary orbit, meant that such satellites could serve as permanent relay stations for communications signals, bouncing radio waves around the world in ways that ground-based towers never could. The idea was revolutionary, but here is what makes it extraordinary. The first actual geostationary satellite would not launch until nearly 2 decades later. Clarke was not guessing, he was calculating. He understood orbital mechanics well enough to know exactly what was possible, even when the technology to achieve it did not yet exist. This represents a special category of science fiction prediction. When someone trained in the sciences writes fiction, they bring a different kind of credibility to their visions. Clarke was not just dreaming up interesting gadgets, he was describing engineering solutions that he knew would work given enough time and resources. The satellites that today carry our phone calls, television signals, and weather data all trace their lineage back to that 1945 paper. Clarke proved that sometimes the most accurate predictions come from those who understand not just what might happen, but why it must. When Star Trek first aired in 1966, the communicator seemed like pure fantasy, a small handheld device that let crew members talk to each other across vast distances. It was the kind of technology that existed only in the imagination of science fiction writers. But something remarkable happened in the years that followed. Engineers who grew up watching the show started building the very devices they had seen on screen. Motorola engineer Martin Cooper has openly acknowledged that the communicator inspired the development of mobile phones. His team created the first prototype in 1973, and a decade later, mobile phones finally reached consumers. Then, in 1989, Motorola released its first flip phone, and the resemblance to the Star Trek device was unmistakable. The design was so iconic that in 2015, the Wand Company created a fully functional replica. It looks exactly like the original prop, complete with a flip-open design, but it connects to modern phones via Bluetooth. Fans can actually own a piece of science fiction history that works in the real world. But the show's influence extends beyond communication. The replicator, a device that could create food and objects on demand, seemed even more far-fetched than the communicator. Yet today, 3D printing technology is bringing that concept to life. We can already print tools, replacement parts, and even basic biological structures layer by layer. A company called Mattershift has taken this idea even further by developing carbon nanotube membranes capable of sorting and assembling individual molecules. Their technology could eventually allow us to pull carbon and other elements directly from the air and arrange them into useful materials. It is not quite printing a hot meal from nothing, but it points toward a future where matter itself becomes programmable. The line between science fiction and reality continues to blur. When Back to the Future Part 2 arrived in theaters in 1989, audiences marveled at the futuristic world of 2015. flying cars and hoverboards got most of the attention. But the film's subtler predictions have proven far more accurate. Doc Brown and Marty McFly encountered tablet computers, video, calling on flat screens, voice-controlled homes, and even fingerprint scanners. Watch those scenes today, and they feel less like science fiction and more like a documentary about modern life. The filmmakers consulted futurists and technologists, and that research paid off in ways nobody could have anticipated. Of course, Back to the Future was not alone in its prophetic vision. The 1992 film Toys imagined a world where military conflicts would be fought remotely using drone aircraft. At the time, this seemed like dark fantasy. Today, unmanned aerial vehicles are standard military equipment, and the ethical questions the film raised about remote warfare have only grown more urgent. Similarly, Wim Wenders' Until the End of the World, released in 1991, featured high-definition, flat-screen televisions. When most viewers were still watching bulky cathode ray tube sets, that prediction now seems almost conservative. Perhaps the most iconic visual prediction in film history came from a galaxy far, far away, when Princess Leia's holographic message flickered to life in Star Wars. In 1977, audiences had never seen anything like it for decades. That three-dimensional projection remained pure fantasy. But in 2017, an Australian company called Euclidean built something remarkably similar. Their hologram table allows up to 4 people to view and interact with three-dimensional projections simultaneously, using motion tracking glasses to create a shared experience that George Lucas could only imagine. Science fiction has always been about dreaming. What comes next? These films remind us that sometimes those dreams become our everyday reality. Something remarkable has happened with science fiction predictions in recent years. The gap between imagination and reality has shrunk dramatically, where Jules Verne waited over a century to see his moon landing vision come true. Modern films sometimes see their predictions materialize within a decade. The 2013 film Her offers a perfect example of this acceleration. Spike Jonze's story about a man falling in love with an operating system seemed like gentle science fiction. When it premiered, yet barely 10 years later, we watch AI systems generating artwork, composing music, and holding conversations that feel startlingly human. The film showed an AI named Samantha creating original songs on demand. Today, anyone with an internet connection can ask an AI to produce a musical composition or generate detailed artwork from a simple text prompt. The timeline between fiction and reality has compressed to almost nothing. Her also imagined video game characters with sophisticated AI personalities capable of meaningful dialogue. Players now interact with NPCs powered by advanced language models that respond dynamically rather than cycling through pre-written lines. Perhaps most striking was the film's depiction of AI systems that could embody historical figures, adopting their personalities and communication styles. This technology exists today. We can now converse with AI representations of philosophers, artists, and historical figures trained on their writings and speeches. Isaac Asimov saw this compression coming decades ago. His Foundation series, written in the 1950s, described devices remarkably similar to modern tablets. Characters carried portable screens that displayed text and images, devices that seemed impossibly futuristic at the time. Asimov waited decades to see anything like his vision become reality. The iPad arrived in 2010, over half a century later. but the pace has quickened. Films released in the 2010s have already seen their technological predictions become everyday tools. We are living through an unprecedented convergence of science fiction and science fact, where the boundary between tomorrow and today grows increasingly thin.